Hey guys, in this video we're going to have a look at simplifying basic surds, and we're going to explain to you some of the general rules to follow when doing this, and then have a look at solving a few examples. So these are the examples we'll go over, but first, before we get there, let's have a look at some of the basic rules to use. So, when simplifying a surd, what we're trying to do is reduce it into its simplest form. So say for example we have square root of 4, we know that this can be simplified to 2. So if we were to have an equation that had a component, square root of 4, it wouldn't be in its simplest form. We'd have to reduce this to the value of 2. So the same thing applies here. However, we also know that some values, such as root 2, cannot be represented in a simple form because it's an irrational number. So rather than representing it as the irrational number, rounded up or rounded down to a certain value, we instead represent it as the surd. So this the main rule or law to remember when simplifying surds is the following: square root xy can be broken down into the square root of x times the square root of y. So that's pretty much it. And the same rule obviously applies going in the opposite direction. Square root of x times the square root of y can be combined into the square root of xy. So this is the main rule to use when solving simplifying surds or simplifying surds within equations. So let's have a look at some examples now. I'll leave this up the top just so you can follow along or remember that as we go. So the first example we'll look at is simplifying the square root of 8. So here, using this rule, we can see that the value 8 can be broken down into 4 times 2. And using this rule, like I mentioned, 4 times 2, we can break that down into square root of 4 times square root of 2. Then we can reduce square root of 4 into 2, and we're left with 2 times square root 2. Or, as we'd write this in surds, just 2 root 2. So that's the simplest form that we can represent square root of 8. So a nice way to check whether you're correct with these types of questions is to punch this into your calculator, see that you get the same result by entering in both of the variations. And of course you will, because we're correct in this case. So let's have a look at the next example now. We have square root of 20. So similarly as we did before, we need to break this down and represent it in 2 separate surds. And you'll notice that a good rule of thumb here is to try and use the square values of different integers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, etc. You want to try and break down your component into some combination or some have at least one of the components be in a square of one of the integers. Then you can reduce that surd into the integer. So here we'll do the same thing as previously. Square root of 20 can be broken down into, this time I'll leave out a step that we did before, square root of 4 times the square root of 5. And of course, square root of 4 can be broken down into 2, and we're left with root 5. And 2 times root 5, just 2 root 5. So it takes a bit of practice, but you'll see it's fairly straightforward once you get the hang of it. So that's our second example. Let's have a look at our third example, which should be root 2 times root 6. So this time we're going to have to move the opposite direction using our formula or our rule, because we cannot reduce root 2 any further, and the factors of 6 are 1, 2, 3, and 6, so there's no way that any of those will reduce any further into integers. Also, it's important to know that often when you have multiple surds in an equation multiplied together, it may be beneficial just to represent them as a single term. So rather than representing them as root 2, root 6, it's better if we can reduce that to a single surd. So that's what we'll do in this case. So we can work the opposite direction like I mentioned, and here we can have the opposite direction, root 2 times 6, which of course is root 12. Then let's have a look at the factors of 12. This time we know that 12 can break down into root 4 times root 3. And here we obviously had an aim to utilize root 4, because then we can reduce that to 2, and we're left with root 3. So 2 root 3 is our solution here. So as you can see, it's better to represent it in this form than as root 2 times root 6. So a fourth example here. Something a little bit more complex this time. 2 root 2 times 5 root 6. So here what we can do is use a variation of the above law and just multiply all the components outside of the surd together. So we're left with 2 times 5. And then we can, under the surd, combine all of the components within surds. So we're left with 2 times 5 outside, and within the square root, we're left with 2 times 6. And this gives us 10 on the outside, root 12, and then reducing root 12 in the same way we did before in the previous question, should be able to see that we end up with 10 outside of root 4 times root 3, which gives us 10 outside of 2 root 3. And then multiplying the 10 through, we're left with 20 root 3 as our solution. So often these just take a little bit of playing around to get to the simplest value. And you may find that you end up with something less simple than what you require for your purpose, but you can always go back or work backwards to get to something that would help you. And last one now, something a little bit different. Root 2 plus root 2. So this is just to make sure you recognize and remember that just as in combining algebraic components, when you add two components together, let's say you have a plus a, the result is 2a. We're doing the same thing here. So where basically root 2 is our variable, we're just left with 2 times root 2, or as we can express, 2 root 2. So that's just something to keep in mind as well when you're playing around with basic surds. So thanks for watching, guys. That's it. Hope you enjoyed. Leave any questions you'd like a hand with in the comment section below. Otherwise, catch you next time. Bye.